Hello. So today this video is about the distributed log using Apache Curator. So the first thing that we need to know is the inter-process mutex API that we have used over here. So it has a simple API where the primary components are the constructor itself, that is how to instantiate a distributed log. Then you can see over here we have the acquire log using the mutex. So this is how we acquire the log, and then the relinquish, that is the release of the log. So prior to entering a critical section, an application or process would need to obtain a log in order to ensure that it is the only one executing that piece of logic. So the main things that you need to look is this line over here. This is the final interprocess mutex, where dmutex equals to new interprocess mutex and the curator client log path. Then to acquire the log, we have this line, that is dmutex.acquire. This is for acquiring of the log. Then at last, this is a line that is important. So here you can see we are printing out the process with the thread, current thread, its name, and the acquired log, its iteration, and the date at which the log is acquired. So here what's important to understand is that this acquire method that is over here blocks until the log is available. So this has some important implications for multiple processes which are competing for this log. So only 1 second succeed. This is obvious, as you can see over here. We have it for only 1 second. So since acquire method blocks, the other processes will queue up. Because acquire method, the other process will get blocked and it will get queue up. So the queuing up will happen in a fair manner as per the implementation. That is, the process which called this acquire method first as per the zookeeper, not as per the application, will be the next in queue to get the log once it's released by the process which actually has the log. And depending upon your use case, you might or might not want the queuing effect. So for example, a node in your application gets locked, finish a part of the job and save it to state to a shared location like a database, and then release the log. So you might want that the other node in that application to continue processing from where the previous node left. So using acquire to let the nodes wait in a queue makes sense. So if you have a scheduled timer distributed across multiple nodes in your cluster and need it to be executed by one node at a time, then you might want to use the overloaded form of acquire method. This will avoid queuing up effect of processes. It's something which you would not want, since the timer is already pre-configured to fire at after certain intervals. Then after this we have the distributed try lock. So just like the try lock method in the Java's lock, the interprocess mutex provides an overloaded version of acquire which accepts a timeout. So it does not block. All it does is the following, that is returns true if the block obtained within the stipulated timeout, and returns false, that is it gives up if the lock is not available and the timeout is breached. So the things to look here is this line, that is final interprocess mutex, demutex equals to new interprocess mutex, Curator client lock path, and the if statement that you will see over here, and the acquired lock statement, that is this one. And so we have it will be acquired lock and the work in progress statements, and then we have the thread to sleep. So here you can see we have the thread dot sleep for 3 seconds. So this is about the non-blocking lock test of Java file that is distributed try lock. As you can see, here is the try. So in the block for lock test, that is blocking lock test, so for both processes that run the task, the for loop will be executed twice. This for loop will be executed twice. So this is because of the blocking queuing effect, and the thread in each process will wait until the lock is released by the thread in another process, and this will happen for the both iterations of the loop. And for the non-blocking lock test, the thread here, as you can see, the thread will wait for simulation, that is 3 seconds, that has been kept lower than the lock acquired timeout, as you can see over here, that is of 2 seconds on purpose. So for both the processes, only one iteration of the loop in the task is executed, either first or second. So this is because the thread in the process which fails to get the lock does not block. It simply returns and repeats the loop, hence misses that iteration of task or job.